we're here today to talk about Reactive Relational Database Connectivity, or R2DBC. My name is Ben Hale. My official job title is the lead of the Cloud Foundry Java experience, and then I see a bunch of people like, whoa, I didn't come to a Cloud Foundry talk. That's very weird to me. That is only my day job, however. I have been a member of the Spring Core team since 2006 or so, and my position as the lead of the Cloud Foundry Java experience, basically, my responsibility is to ensure that applications running on Cloud Foundry, written in Java, are the best they can possibly be. Originally, my mandate was to make Cloud Foundry the best cloud to run Java, and lately it has more evolved into make Cloud Foundry the best place to run Java, not just the cloud. And so in my position, working on things like the Java build pack and the Cloud Foundry Java client and things like that, one of the things that I was I had a first-hand perspective on was the rise of reactive programming in our Java applications that are running in the cloud. And so this led me to sort of get involved in Project Reactor. It's been a very good day for me, obviously. You guys saw in the keynote this morning, Reactive Relational Database Connectivity. I also spearhead the efforts for the company, working with RSocket, which was announced at the end of it. So it's been a pretty good day for projects that I'm interested in, and especially reactive projects that I'm interested in. So I personally believe reactive programming is the next frontier in Java for high efficiency applications, right? We can sit here and say that reactive programming is a bit more difficult, certainly today, than traditional imperative Java programming. However, there are circumstances where sort of the one thread per connection model just absolutely breaks down. It cannot scale to the kinds of loads and the kinds of workloads that we need in our applications. And to date, the only real alternative that we have in the Java community is to go with reactive programming. And so just to set some, a level set everybody here, actually, how many people program reactively today, whether you're using RX or you're using Akka or you're using Project Reactor or anything like that? How many people? Okay, a small number. So I will try and ensure that I explain a lot of the reactive terms and things like that as I go along. If not, feel free to raise a hand, interrupt me, and I'll see if I can clarify for you as we go. So reactive programming is fundamentally about writing non-blocking code. So if you are familiar with programming in Node.js or something like this, the fact that there is one thread, or in the Java case, as Ross mentioned in the keynote today, typically it's the same number of threads as you have processor cores. It just means non-blocking, right? We'll talk a little bit about it, back pressure in a second. But one of the key things is it actually means almost nothing about asynchronous computing. It is paired with it, but reactive programming doesn't necessarily imply an asynchronous kind of behavior. Most flows, if you're a reactive programmer already today using something like Project Reactor, are 100% completely synchronous, because it is the most efficient way to actually run an application given you have access to the core. Reactive programming talks about what happens when you need to wait on something, right? You don't want to block for that. You want to get off of that core and let someone else make use of it in a highly efficient way before you jump on it. But one of the key differentiators, and this is going to come all the way back at the very last slide here, is that async is not reactive. You're going to hear a lot of people tell you that, oh yeah, my thing is async, right? I don't block on a thread or anything like that. But that's not what reactive is. The key differentiator is that reactive is all about what we call reactive streams back pressure, reactive back pressure. You'll often see it written as pull-push back pressure. And the key kernel of this idea is that when a publisher needs to send data to a subscriber, so basically a producer to a consumer, it is not allowed to send data, and therefore it doesn't need to even materialize the data that it might potentially send until the consumer is ready and has asked for it. So in the reactive streams way, it sends basically a request of n. I want you to send me the next 8 items. I want you to send me the next 32 items. I want you to send me the next 1024 items. And then the producer is able to produce exactly what it needs at that time to fulfill that request. It doesn't have to send all of them. It could send 10 and then wait a couple of minutes and then send another 10 and then wait another couple of minutes. Or if it's got 10,000, it only gets to send the first 1,000 and will eventually then, the client, when it has processed them and it feels it has the availability, will then go and request an additional 10 or an additional number of items that it can handle. And so we've been talking in SpringOne for the last 3 years, actually. 3 years ago, we got on stage and we started talking about this reactive thing in Project Reactor. Like, we've got Java 8, almost everybody's on it now. We've got Lambdas, which make a nice programming model around this. We can start doing reactive. And then last year, Spring 5.0 came out, and it's all reactive, right? Not a replacement for the imperative stuff, but we've got WebFlux, we've got WebClient, we've got Reactor Core becoming a core dependency, only the second mandatory core dependency ever in Spring Framework's history, and I've been around basically since the beginning. It's an amazing thing that such a thing can happen. But it tells you how much we think reactive programming is going to be important going forward. And so if we take a look, this is just your sort of standard web client thing, right? We've got an annotated controller. It returns a reactive type, sort of lazily initialized health, and it does this by doing a composite, zipping together, calling to 2 other services so it can represent itself as a single authority there. That's all well and good. Hopefully some of you have started experimenting with it, even if you're not doing it in your day job. But there are still some barriers to using reactive everywhere. And I put a little star there because there are certain true believers, you might call us, that really do think that eventually it's all going to be reactive. You don't have to think like that, and you shouldn't think like that as that is not an official position of anybody in the Spring team. That is my own personal opinion. But when we say reactive everywhere, what we really mean is everywhere that it's appropriate. So today there are these high efficiency use cases that we're talking about earlier. Those are really obvious places that you want to use reactive programming, but that absolutely does not mean that you can use reactive programming today. So cross-process back pressure is one of the things we don't have, except as of about 30 minutes ago, we do have it, RSocket, and I encourage you to take a look at the one that's happening right now if you want to rip over to the RSocket one, and also I'll be doing a talk later this afternoon about RSocket as well. And we also don't have very good data access, right? Going back to data stores. There are certainly a number of reactive, especially NoSQL data stores, things like Mongo, Cassandra, Redis, things like that, as were just shown in the previous session from here. But to date, we haven't really had access to the #1 data store by a far margin that all of you are using. Relational databases, right? This has been an absolute stop. If you have an application that would immediately benefit from using reactive programming, you're hosed. You don't get to do it if you're trying to connect to a database via JDBC. There's no way to get good stuff there. And so, R2DBC. So R2DBC came about as we sort of, we did year 1 of here's Project Reactor. We did year 2, which was here's all the stuff in Spring. And as we start working towards year 3 and what our reactive story is, we start saying, okay, we've sort of taken down the low-hanging fruit. But we haven't, there's still these places that stand out that aren't good enough. And so we had some meetings. Traditionally, at the end of SpringOne, there's always a big engineering team meeting where the Spring team's massively distributed, so we don't really get to see each other in person very much. But this is one time where we all get in a room, we all hash out, what we're thinking about for the next year. And the letters R2DBC were said, the idea was sort of put out there, and nobody really wanted to do anything with it. We have engaged with the JDBC spec team around ADBA, which we'll talk about a little bit later, and we thought we might have some traction there, and some time went on. And so when I said a little bit earlier, I can't believe this room is this full, and it's because, we didn't think this was actually that pressing of a problem, that people were using NoSQL, or they were dealing with this in some other way. But then sort of December rolls around, work slows down a little bit, I'm stuck at my in-laws' house and didn't really want to be talking to people. And over a couple of weeks, I sort of sat down and said, let's do this. Let's see what R2DBC is, just sort of in my spare time. And I am absolutely astounded and amazed and absolutely appreciative that you guys have all come here to hear about it. So R2DBC comes from this idea that we sat down and said, JDBC can't work. There's absolutely nothing you can do to make a blocking API truly reactive. That's just sort of first principles. So if we were freed from that, if we were freed from the restrictions of we need some kind of backwards compatibility, and we are the experts in reactive programming in Java, what would we design, right? And there's really 2 components to this. One is taking a look at what does a reactive API look like? And you need some experts in doing reactive programming, but also what should database access, what should relational access look like in Java? And for this, you need people with decades of experience dealing with JDBC and dealing with enterprise customers and dealing with JDBC. So we came up with a set of design principles. First and foremost, we're going to utilize reactive streams, types, and patterns. And we're going to see this all throughout the API today. Second, must be completely non-blocking all the way to the database. And this is a key thing, and one of the places where, a number of other attempts at this kind of thing have broken down. Simply wrapping a JDBC driver in a thread pool is insufficient. We'll talk a little bit later why that is. 3, and this gets to that second audience that we're talking about. We want to shrink the driver SPI to the minimal set of operations that are implementation specific, regardless of their usability, okay? We'll talk a little bit on the next slide about exactly why this is key. And then finally, we want to say that there should not, in the way that in JDBC there is sort of an official client for how you deal with JDBC, and it has turned out to be so bad that everyone has chosen to build a million other clients on top of it. We want this separation between the driver SPI being very, very small and tailored directly to driver implementers, while enabling all the functionality required for you all to write exactly the client you need. So the driver SPI, as I say, one of the biggest failings was we had the same API that driver implementers had to sort of do to enable these rich clients to sit on top of it, like JPA or Juke or something like that. But then it also had to be the one that, if you chose not to use this, if you just wanted to stay, sort of plain vanilla, you as a user also needed to use that same API. We had this conflation between things that were good for machines and things that were good for humans. No one liked it, right? I have spent some time recently with JDBC driver vendors, super not amused with the JDBC API. You got to do it, but it's not the easiest thing to do. Whether it's implementing a bunch of methods that they don't really need because some database at some point needed them or some client thought it was a good idea to get this in there, or duplicating functionality that all driver vendors have to implement but cannot reliably share with one another. And the canonical example of this is a humane affordance like the question mark that we've all used in JDBC queries has to be implemented by everybody, even though the way it works, like turning this thing into an index into an SQL query, works in exactly the same way in all of these databases. Everybody gets to implement that from scratch with just slightly different semantics, just slightly different bugs, and you end up with a thing that's just really, really painful for driver implementers to do. So I'm going to go through a couple of the major types. The driver SPI itself is relatively small. I think including enums, interfaces, and types, it's about a dozen classes or so. And I'm not going to go through all of them, but I'm going to hit the big ones. There's a connection factory that hands you back a connection using a mono to return it, so it's lazily initialized. You don't actually ever even call for a connection until you need the connection to actually send data. So you could potentially write a class that calls for a connection on startup, and that connection is never actually provisioned for a couple of hours, maybe. But the connection is sort of where the rubber meets the road, the core of what makes R2DBC. And you're going to look at this, and a lot of actually these methods, I am a stickler for verbosity. I like things to be very clear, very well named. We're not paying by the character or anything. We all have autocomplete in our IDEs at this point, so I like relatively long names. But it talks about this, the design principle that we needed to implement the smallest possible thing that is database specific. Exactly how transactions are created, exactly how they're committed, what it means when you're trying to do batch, like a batch insert or something like that, how save points and transaction isolation, all of these things work. A driver implements this core of, what do you think that is, about a dozen methods, and that turns out to be the core of what a JDBC driver does uniquely from all other JDBC drivers. I'm going to skip what batch does because it's super simple and looks relatively like this statement thing. Statement, for those of you who are familiar with the JDBC driver, there is a statement thing, and then there's a callable statement, a preparable statement, and this turns out that the semantics between the two aren't really reflected by databases any longer. They have this artifice that they all basically channel back to the exact same call that looks like a prepared statement effectively in their underlying wire protocols. So collapse all of that down and say, okay, here's a statement. And a statement, when you create one of these things, you're typically going to put some sort of SQL query in, and you want to have the ability to bind a bunch of things to it, right? You want to bind by, we have object identifier, so if you're in Postgres, is the one we're going to talk about the most today. Identifiers natively in their SQL variant are $number, right? So $1, $2. So you might put that in there, or if you're going on to Oracle and they use named parameters, maybe it's :foo and then whatever the value is. Binding to a numerical index, binding null, where you always have to have a class type. So those sort of get unique things. But then there's this add method that sits at the top, and this is sort of the concept that all statements should be prepared statements realistically. Once you have one of these things and it's negotiated with the database, you want to be able to bind a bunch of parameters and say, this is going to be my insert statement, add that into a queue, bind a bunch more, add it into a queue, bind a bunch more, add it into a queue, and then finally executing where inserts, for example, generate keys that need to be returned, auto-generating keys. That execution returns a result. And a result is relatively simple. It'll give you, again, a lazily initialized number of rows that are updated, or it will effectively hand you an iterator. Sort of, we would refer to this as a mapping function using a by function here, where you get a row and you get metadata about the row. So you get, here's this thing that has all the data in it, here's this thing that tells you about the types it was stored inside the database, and you are responsible for using that to convert it into T's, whatever object you want them to be. Maybe you just return the row because you want to use it a little bit later, or maybe you're the kind of person who wants to do a manual object mapping in here. These are sort of the primary things people want to do, is get my data, and a function can be just an identity function that returns the initial thing, or they can do some sort of limited transformation. Do you have a question?
On the previous page, you had differentiated between get result and get result with generated keys. It didn't look like there was a way to result to get the generated keys.
So the execute returning generated keys will hand you a result. This may be sort of the kind of thing where this is a distinction that doesn't actually matter once we start implementing other things, but certainly right now we think that the idea of doing an execute, like you could imagine an insert statement with execute that didn't return anything would just end up with an empty result set, versus an insert statement where you're intending to get a bunch of generated keys back does actually return a result set with those generated keys in it. Yeah. And then finally, there's no header for it. The get at the bottom is basically, here is my row. I'm going to take an identifier, go get me column foo from this row, and I want you to convert it to this particular type. And database vendors and all of sort of the JDBC implementations have a canonical list of what they think their SQL data types map to in the Java world. So to take a look at what some of this code actually looks like, and there are some example projects. We'll take a look a little bit at the end at the GitHub repo, and I can show you where some of this stuff is. You have a connection factory, create, which will give you a mono of a connection, as I said. And then we typically do something like a flat map many. We get access to the connection, we create a statement, and we execute that statement. The thing that is returned, that result, we then map in some way, and we say, here's my row and metadata, I want you to go get me the value thing. So the net result of this invocation is only at the end when somebody subscribes, it goes and grabs a connection, executes the query, and for each one of those rows, I'm going to return whatever the value is. Let's call it an integer, right? It's just 1, 2, 3, 4, 5. And this results in a flux of integers as the end result, with a life cycle around the connection that's only on subscribe and closed off once it's complete. This will return a flux right here because of the flat map effectively at the end that turns a single mono result into a bunch of rows effectively, or a bunch of things mapped out from the rows behind it. Yeah, absolutely. It's a good distinction to ask. There are places in here where you might get mono. So instead of asking for the result.map, If we'd gone for just give me the get rows updated, you'd typically get a mono of that integer back because it's only a thing. One of the things that this does point out, you'll notice the spec is written in terms of this thing called publisher, right? And yet I'm talking about fluxes and monos with the audience right here. The spec itself is written to reactive streams. Reactive streams is sort of a neutral third party that defines publishers and subscribers and things like that. It's sort of a specification that allows interop between multiple different reactive streams implementations. But the reason it's critical to use it when defining a spec like this is there is an equivalent from Java 9 on called flow, and flow contains the exact same types with the exact same semantics and the exact same definitions as exist in reactive streams. The implementations that we do, well, we're a project reactor house, obviously, and so we have flux and monos, and we return those directly if you are also a project reactor kind of place. But if you're not, the fact that I have returned a mono doesn't matter. It's a publisher. It means you can translate to RxJava or something like that. Maybe we want to do an insert, and this is sort of a demo of that binding that we talked about a little bit earlier. Get our connection, create our statement, binding to the two values, do an add. There is an implicit add when you do an execute at the end, so you could do it manually if you wanted to, but it effectively results in inserting 2 rows into this particular application. Now we start taking a look at the more complex stuff. Prepared insert inside of a transaction. So now it starts getting clunky, and like I'm confident enough to say this is not great. This idea that connection begin transaction returns a mono void. Basically, it signals, yes, the transaction has been opened. And then you have to then many it with this thing, which was the thing that existed outside the transaction. Then we have to commit the transaction. If something goes wrong, we need to roll back the transaction and propagate the error and stuff like that. And this is where we start to see this distinction that this API, while being super concise and focused on implementers, isn't super humane. Because clearly you want to do this, right? It's a bit verbose, and especially that bit at the bottom, it's going to be prone to errors. This is this set here down at the bottom that's delay until on error resume is effectively try catch finally try catch. And I suspect there are some JDBC developers in here who are young enough who don't remember the bad old days where every single bug was because you didn't do try catch finally try catch properly with JDBC. Thank God, we've got things like auto-closable and JPA to take that off our hands these days. So what we actually need is a humane client that gets built on top of this. But more importantly, we don't need one. I can't decide for you, certainly as a spec lead, a prospective spec lead on this, I can't decide what everybody's going to need. I don't have the same programming styles you do. Clearly, I like really long method names. I'm sure a lot of you hate really long method names. And so what we want is sort of 1,000 clients to bloom around this kind of thing. So I've got some ideas. The very first example we saw there, R2DBC with handle, select this thing. This is a slightly different variant because it doesn't give you like row metadata and things like that. It's somewhat simpler. I don't ever deal with running execute. I don't ever deal with getting the row mapper back from the result or anything like that. It's all hidden away. You can get to it if you want to, right? That's the whole point of having this lower level SPI, especially if you're a client implementer. This is implemented in the terms of the driver SPI, but it says most people probably want to run a select statement and map those rows out, and we'll take care of everything else that goes on inside of it. What about that insert that we saw a little bit earlier? Create an update, bind, add, bind, execute. So you still get those same kind of behaviors there. Because binding takes multiple things, we obviously need to expose execute in this case. One of the keys is this execute doesn't sort of give you that access to the result. It assumes that most inserts just want the number of rows returned. And I think in reality, for most of us, we don't actually care even about that number, right? You just want to insert these things and yay, it's good to go. So final one is, what about that transaction one with all that sort of delay until on error resume behavior at the end? What if it just looked like this? What if, because of how these closures work, we could bake that same boilerplate into a client? So now we just say, I want this to be in a transaction. There's even a field on the before the closure and an overload of this that will allow it to take your transaction isolation level that you want to use there, right? I want to execute these always serialized or something like that. And so now you start saying, this is actually interesting, right? This is a client that is humane. I haven't subjected every single driver implementer to having to implement that exact same boilerplate about how to wrap this thing. But as we said a little bit earlier, and especially if you were in Chris's talk beforehand, this is sort of JDBC template level stuff. And that's, most people these days, that is not your speed, right? Everybody wants something like Spring Data repositories. So what if there was a client that looked like that? Right? Find by last name, it's got some query assigned to it, returns a flux of customers so that you can just call it and you get a flux of these things back. This is an example of yet another client that can be built on top of that same driver SPI. We have this today. Obviously, it's in Loveless and boot 2.1.M4 as well. So what about alternatives? We talked a little bit earlier about JDBC and a thread pool. If you tried to implement this with JDBC inside a thread pool, there are two problems. One, there is no such thing as back pressure, right? Every single one of those behaviors that we saw, every single API that you might call has this underlying implication that when I'm a client and I call that database and I'm like, give me 100 million rows, the database has no way of ever sending 100 million rows to me, blowing up my heap and taking down my VM. What happens is I ask for 8. And then it is responsible for holding off and only sending me 8 when I'm ready for them. Maybe you want bigger numbers. There are ways to configure these things. Maybe you can handle 64 in a row or 128 in a row or something like that. But one of the really interesting side effects of this is it actually helps databases themselves as well. Because a well-written driver like this will actually make it so the database never even materializes those rows. They're literally never read off the hard drive in the first place. And so rather than having a bunch of people all asking for 100 million rows simultaneously and then having to materialize and transmit across TCP, say 5 times 100 million rows. What ends up happening is everybody gets to make that exact same query, and now it only reads enough from the hard drive to send 5 times 8 rows, right? And that's this underlying implication. So you could never get any of that if you were just using a JDBC driver. But beyond that, the queue, this pattern where people think, oh, reactive means I just need to be non-blocking, and so I'm going to wrap something in a thread pool. What ends up happening is the queue of you trying to get things into that thread pool either is unbounded, at which point you end up with requests that explode, and you basically take out your heap because you've stored 100 million pending requests, or that you choose a bounded queue, which is a hell of a lot safer, but that's going to actually lead to blocking. It actually makes the whole system back to blocking, because when you try and insert that 64th or 128th or 100 millionth request that hasn't yet been serviced, it will eventually block that thread that you made the call. And as we said earlier, when you're doing reactive programming, it's not like you've got 200 threads to play with. You got 4 threads to play with, or you got 8 threads to play with. So blocking one of those, really, really bad idea. ADBA, the elephant in the room, or the elephant emoji in the room. I think those are a little bit smaller. We have, as Ali mentioned today, we engaged pretty early with the ADBA crew on this, but there's a lot of contention whether or not completable future is actually reactive. I'm not here to sort of crap on ADBA. I'm happy to talk about the technical issues later. Suffice to say that it's not reactive. It can't do back pressure. It doesn't do those kinds of things. And we sort of disengaged, and that led to the R2DBC effort. But now that the R2DBC effort has actual proof and working APIs, we're being invited back to engage again. And so ADBA may yet become this. And I think, sort of to some extent, that is the end goal of a project like this. So, safe harbor statement. This basically means I'm about to tell you something that doesn't exist. R2DBC was originally envisioned as an API playground. As I said at the beginning, we effectively said, if we were not constrained, what would we design? And more or less, that means what would I design personally? There has been some input from the Spring Data team after the initial one was made. But it's still up for discussion. And it's so great to see so many people in here so interested in this, because it gives you an opportunity to have a say in a spec like this. And I dare say more of a say than you would have if you were trying to influence the JDBC spec. We obviously, so the code itself, I think is absolutely great for you to start testing against. Please, for the love of everything, do not take this into production, okay? Not production. But it is stable enough for you to start writing applications and testing on something like this. There are a lot of edge cases. For example, no blob and clob support, right? Only Postgres support. We actually talked to Steve Gurry, the Facebook guy that was up on stage this afternoon, offhandedly mentioned last night around 2 in the morning when we were all still working on our slides. Oh yeah, I've totally implemented a non-blocking asynchronous MariaDB driver. Hasn't everybody? And so like we actually have an avenue to getting a MariaDB implementation of this quite quickly. Probably want at least one other client. Who knows what it's going to be? I have already been talking to someone over Twitter that I have invited to contribute a driver for their database. The big takeaway for me doing this kind of work, it turns out database drivers, not that hard. I've been doing Java programming since the late 90s, and I had always assumed to do a JDBC driver, you had to be the smartest developer in the world. Most of them are actually not great inside anyway. They have a lot of legacy cruft to them, but it's actually not that hard. So if you think you have a database that isn't likely to be tops on the list, you can do it, and I'm happy to help, right? I'm available on Twitter, the GitHub repos we're going to see in a little bit. I am happy to help you make a contribution to this project for a database that matters. Finally, Spring doesn't generate specs, right? We aren't spec leads. We don't host specifications. We're happy to be a de facto specification in the case of the Spring framework. But realistically, this project's entire goal is to become a way to influence the ADBA spec. That is sort of the best possible scenario. But make no mistake, I am not a person who's going to tolerate the ADBA spec being bad. Right? If they don't take our advice, if they don't see that reactive is different from being async, this is something that the Spring team will do, right? There's clearly enough demand in this room. People want to do reactive relational data, right? They need the reactive bit. Being asynchronous is not sufficient, and we will make this a project, and we will implement drivers, and we will work with database vendors to guarantee that you, the community, have this kind of implementation. So finally, R2DBC IO. Let me pull up a quick web page here. Go away. There we go. So the easiest way to get there is r2dbc.io, written very, very tiny right here. It takes you to the GitHub org. The main 3 things you're going to see there, there are a couple of other things around CI and stuff like that, is the R2DBC SPI, which is, as you'll find out, very small, bunch of interfaces basically, and lots of documentation written against the reactive stream specification with an eye towards it should actually be against the flow specification. The R2DBC client, which basically could have any underlying strata underneath it. You build some sort of client. This is one potential client that looks a lot like JDBC template. We want to see a lot more. And a Postgres implementation. And I would love for this list to start moving right with other databases underneath it. And I would love all of you to come and contribute and say, hey, here's a use case that I've got that your API, your driver API, or your client API doesn't actually support today. We want to make sure that it can do this thing that I absolutely need. And with that, let's call it a day. Thank you all very much for coming. I'm happy to take questions up here now.